Okay, guys, before we move on, I actually found this other simulation that I really like as well. You can select a glass rod. Oops, let me get my pen away. You can select a glass rod, which is positively charged, or you can grab a rubber rod, which is negatively charged. But notice what happens when I bring this positive rod near the plate. It's attracted to it. That aluminum plate is neutrally charged. Now, I haven't shown you the charges, but what do you think's going on? Why is it attracted? Same idea of polarization. Remember, this rod is positively charged. The aluminum is neutral. Something has to be happening in order for it to be attracted to it. So let me show you the charges. Polarization is occurring. Notice how those electrons are moving to the side closest to the rod. That's because there's a force of attraction between the positively charged rod and those electrons within that structure. Now, aluminum is a conductor, so that's why those charges are able to move freely throughout the structure. Okay, let's look at the rubber rod. Let's just get the positive guy out of there. Oops. See if I can grab him. There he is. Okay, I don't know why it keeps doing that. Okay, so notice how the electrons are now being repelled. And we still have a force of attraction, but that's because the side closest to this negative rod is more positively charged because we have repelled the electrons to the other side. So this is polarization once again. Okay, we're just redistributing the charges within that neutral object. That's all we're doing. All right. Okay. Now, let's go back to our PowerPoint presentation. So, here are some definitions for you guys to get down. An electroscope is a device that detects the presence of an electrical charge. You can kind of Google this and go through videos if you'd like. There's so many different examples if you want to see what it looks like, but it just detects the presence of electric charge. Okay. Now, I mentioned this earlier in my previous video. Only electrons can be transferred from one object to another because the protons and neutrons are fixed in the nucleus. Remember, follow the electrons. Follow the electrons. You can fit it. Okay, follow the electrons. All right, now, a conductor. Talked about this too. Conductor, material that transfer electrons easily. Well, why is this? Because those electrons can move freely about the structure. Okay, now, I don't know if you guys remember this from chemistry, but I'm going to show you. This is what the structure of a metal looks like at the molecular level, or at the, I should say, the subatomic level. Okay, let me change this font to a little bit more. There we go. Okay, so metals are positively charged. Okay, so I'm going to use positives to represent the metals. Okay, now, the electrons within a metal, use E negative, E negative, E negative, E negative, E negative. Okay, I'm just going to draw some in there. Now, in metals, they're able to move freely about the structure. They're able to move freely, going from atom to atom easily. This is known as the electron C model. Electron C model is for all metals, and we know metals are conductors, and conductors allow for their electrons to move freely about the structure. That's why they're able to be transferred easily, and that's why they're polarized at larger distances, as you saw in those simulations. Okay, so conductors, electron C model. So there's a little bit of chemistry behind it. Okay. Now, number 2, insulators. Materials that don't easily transfer electrons. Example is glass, plastic, rubber. This is because their electrons are more tightly bound. Okay. Number 3, semiconductors. Now, if you remember from chemistry, these are your metalloids, your semiconductors. They have both properties of conductors and insulators. Okay, so their electrical conductivity is somewhere between, let's say, copper and glass, right? So they have properties of both, but their electric conductivity is a little bit less than, let's say, a conductor, and a little bit more than a basic insulator. Okay, now, where do we use semiconductors or metalloids at? These are your computer chips, your silicon computer chips, your germanium computer chips. Okay. Superconductors. These are perfect conductors at or below a certain temperature. So, if you have a perfect conductor, that means it can conduct electricity, can transfer electrons perfectly. That means with zero resistance. There's no resistance to any electrical charge. These materials transfer them perfectly. Okay? All right. So basically no resistance. Let's move on. Now, there's a couple ways of charging an object that I want you to know, and we're going to cover them both. The first one is conduction. I talked about this briefly in another video. Okay, conduction is charging by contact. So you're physically touching another object and transferring charge. So rubbing two objects together, the electrons transfer from one are transferred to the other. Okay, one object becomes negatively charged and one object becomes positively charged. Right? So like rubbing the balloon against your hair. Okay, the balloon gains electrons from your hair. The balloon becomes negatively charged. Your hair becomes positively charged because it gave those electrons to your balloon. Okay, and as a result, opposites attract. One's negative, one's positive. Okay, you can also see it right here. Let's say we have a negatively charged rod, as seen in this picture, right here. Let's say we were to touch that negatively charged rod to that neutral pith ball right there, pith ball. Okay, if you touch the negatively charged rod to the ball right there, notice how electrons transfer from the rod to the ball. Okay, it transfers from an area where there's more electrons to an area where there's less electrons. Okay, and then as a result, you're charging that ball. So now you have an object, or you have two objects that are negatively charged. And as a result, they will repel each other. So that's another example of charging through induction. You're transferring electrons through physical contact. Okay? Charging through conduction. All right? Now, charging through induction. Okay, this is a little bit more difficult. Let's go over a couple key terms first. Okay, so when you ground something, when an object is connected to the earth by a wire, pipe, finger, etc., electrons can transfer to or from the earth. Okay, the earth is this infinite reservoir for electrons. It's so massive that when we connect a wire to or a pipe to the earth, it can transfer those electrons into the earth, and the earth will be totally fine. Okay, it's because it's so massive. Okay, it can accept or donate an unlimited amount of electrons. All right, that's why if you go by and you see those electrical poles, you'll see a wire going down the pole connected to the ground. It's grounding. It's connected to the earth. All right. Now, to understand this idea of induction, let's go through a specific scenario. Okay. So, here it is right here, and these points explain what I'm going to explain right here. Okay, so you can go through it on your PowerPoint yourself. Okay. Now, let's say we have this neutral sphere. Okay, this is number one. We have a neutral sphere. Okay. Now, if we brought this negatively charged rod near the sphere but did not touch it, what are we doing here? What are we doing? What is this phenomenon called? We're not touching it. We're just redistributing the charges. Okay? This is polarization. We're inducing the charges, essentially, right? So the first part of induction is that polarization that's occurring. So what's happening is you're pushing or repelling the electrons to one side of the ball. So this side's more negative, this side's more positive. Now, let's say we were to attach a wire to this rod, to this sphere. I'm sorry about that. If we ground something, we're attaching it to the ground. So electrons from the ball can move through the wire into the ground. Well, if electrons are moving from the ball into the ground, you're actually losing negative charges. So now the ball is positively charged because you lost those electrons. Okay? So let's recap one more time. Okay? We have this neutral sphere. We bring this negatively charged rod near it, but do not touch it. Okay? This point, we've polarized the ball. This is not induction yet. Why is this not induction? Because induction has to do with charging an object. We have to gain or lose charge. Okay? The only way to gain charge is if we ground it. When we ground it, we're attaching it to the ground. Okay? And when we attach it to the ground, the electrons transfer from this sphere through the wire into the ground. That's because we're repelling it. Okay? There's a force here, there's a repulsive force here that's pushing those electrons into the wire. Once it gets to the wire, we know the wire can run into the ground. Because there's a place of a higher electrons to a place where there's lower electrons. Okay? So it will flow from the wire into the ground. Or I should say through the wire into the ground. And as a result, since we lost those electrons, the sphere is now positively charged. This is charging by induction. Okay? And it's explained right here. Okay? There's another scenario here you can go through. Okay? We're saying this is the same exact idea. Okay, got a neutral sphere. Bring that negative rod close to it, but do not touch it. We polarize it, pushing those negatives to the right side. If we attach a wire, boom, negative charges run through the sphere, from the sphere into the wire, into the ground, and now we can move everything away. We can move the rod away. We can move that away, and we know it has now a positive charge. Okay, charging by induction. All right. Polarization. We talked about polarization. You guys can re-go over this. Okay, something that's polarized. Now, I added a Coulomb's law slide because some people are asking about Coulomb's law, still a little bit confused, so let's kind of go over it. All right. So, Coulomb's law is all about the electrical force and how we find the electrical force. Whether the force is attractive or repulsive, we still use Coulomb's law to find that out. It's just the electric force is just a force between two objects of any charge. Okay? Now, breaking down the actual formula itself, Fe is the electrical force. K is the Coulomb's constant that was discovered. Okay, that's 9 times 10 to the 9th. You may see 8.99 times 10 to the 9th, but I'm okay with you using just 9 times 10 to the 9th. Q1 and Q2 are the two charges. Remember, they can be positively charged or negatively charged. Okay, and then D is the distance between them. Okay, so Fe is equal to K times Q1 times Q2 divided by D squared. So if you remember, this looks exactly like the universal force of gravitation equation. All right, so here's a relationship. I broke down the relationship between the force and Q1 and Q2. They have a direct relationship. So let's say if you double Q1, you're going to double the force. Let's say if you double both charges, if you double Q1 and Q2, you're going to quadruple the electric force. Okay, they have a direct relationship because look, they're both in the numerator. They're in the numerator. Okay. All right, now, the relationship between the distance and the electric force is an inverse square relationship. Okay, an inverse square. So let's say you were to double the distance. That must mean, how would the force, the electric force, be affected? Well, if it's an inverse square, the inverse of 2 would be 1/2. An inverse square would be 1/2 squared, so it would be 1/4 as large. If you triple the distance, same idea. It will be 1/9 as large in terms of the electric force. All right, so that's the relationship. In any case, in all of these problems, I will give you enough information to solve for whatever variable you need to solve for. All you're doing, you're just plugging in and you're chugging. Plugging and chugging. That's it. All right? Okay. Now, here's this last slide. I want you to go over. You can go over it itself. It's very self-explanatory. It kind of compares the force of gravity with the electric force, those equations, and the differences between them. Okay? Like I said, I will post this for you guys. If you have any other questions, do not hesitate to email me or message me on Canvas. All right, hope this helped.